I'm going to show you how to determine mole ratios using balanced chemical equations. When you have a balanced chemical equation, it tells you how much of each chemical is used or produced in a chemical reaction. So in this example, we see that it says 2A gives you 3B plus C. And what this really means is that this reactant A, if you have 2 moles of A, it will decompose into 3 moles of this product B and 1 mole of this product C. And we're assuming that this is a balanced equation. So this is important to know in order to calculate your mole ratios. Okay, step 1 in calculating your mole ratios is to balance your chemical equation. And in this example, we have that carbon disulfide combines with oxygen gas to give us carbon dioxide and sulfur dioxide. And go back and review your balancing equations, and you'll find that the coefficient that goes in front of this O is a 3, and the coefficient that goes in front of this sulfur dioxide is a 2. Alright? And so what this tells you is that for every 1 mole of carbon disulfide, you will combine 3 moles of oxygen gas, and that will form 1 mole of carbon dioxide and 2 moles of sulfur dioxide. Now, in order to do these mole ratios, we're going to go ahead and put in the 1s in front of this carbon disulfide and 1 in front of this carbon dioxide, because we're going to be actually using those numbers in the mole ratios. So in step 2, what we're going to do, we have our balanced equation here. In step 2, we're going to make ratio pairs with all the chemicals. And that's each one of these, each chemical here will pair up with each of the other ones. And then we use the coefficients as numerators and denominators. So let's see what this looks like. Okay, once again, we have our balanced equation up here. And so we're going to look at the mole ratio of carbon disulfide to oxygen gas. We know that for every 1 mole of carbon disulfide that we use, we will use 3 moles of oxygen gas. And so we can compare now carbon disulfide and carbon dioxide. And for every 1 mole of carbon disulfide we use, we're going to produce 1 mole of carbon dioxide, and so on and so forth. For every 1 mole of carbon disulfide, we'll produce 2 moles of sulfur dioxide. And then for every 3 moles of oxygen gas that we use, we will form 1 mole of carbon dioxide. And for every 3 moles of oxygen gas that we use, we will form 2 moles of sulfur dioxide. And finally, comparing these two products, for every 1 mole of carbon dioxide that we produce, we will produce 2 moles of sulfur dioxide. So this is how you determine your mole ratios. You can see how important it is to know how to balance your chemical equations. So in summary, the way that you determine your mole ratios is 1, you balance your equation, and then 2, you use your coefficients to make your ratios.